For our next program, we're going to take a look at a simple addition program that asks the user to enter two whole number integer values, calculates the sum of those values, and displays the result. And this is, of course, our most complex program so far, but it does introduce several new features that we need to talk about. So we'll go ahead and load up that program, which is from the figure 3_14 folder. And you can see here I've named the file addition.cs. Once the source code is displayed over here, you can see that we have many more statements than what we've looked at so far. And let me just go ahead and run this program first so you can see it in action. So the first thing we do is prompt the user to enter an integer. So I'll type 100. I then prompt the user to enter a second integer. Let's say I type 23, and it displays that the sum is the sum of the two values that I just specified. So just a very simple addition program. But there are, again, a number of new features that we want to take a look at here. So first of all, you'll notice that the basic setup of this app is the same as the earlier apps that we've been looking at. We've got a using directive that says we're using some features from the system namespace. In particular, we're using the console class from the system namespace, and you can see when I click in console, it highlights every use of that class throughout the text editor here, so you can see all the different places it's being used. Another new class that we're going to use in this example is the convert class, which is also in the system namespace. A lot of the fundamental classes that are used in many programs are defined in the system namespace. Now, for the first time in this program, we're going to be declaring variables and doing user input as well. Once again, we have a class. In this case, the class is named addition. Capital A by convention, and again, notice as I select the first line of the class, it also highlights the curly braces that define the body of that class. Similarly, if I click on the curly brace of a method, you can see that it highlights the closing curly brace. For any opening curly brace you click, it will also highlight the closing curly brace, so you can see the full block of code that it represents. Now, within the main method, which is again the launch point for your application, what I've done here is declared a few variables. Now, I don't need to declare my variables here in this program. I can declare them as I use them, but we decided just to declare them up front for discussion purposes here. So we have three int variables that we've declared. Now, the keyword int indicates a 32-bit integer in C#. And that's different from some programming languages that some of you may be coming from. You have a similar concept in Java, where Java uses fixed size types. But in C and C++, for example, the concept of an int could be 32 bits on one system and 64 bits on another and 16 bits on yet another. So one of the nice things about the .NET framework is that your primitive type or built-in type or fundamental type types are all fixed sizes. And as I hover over int, notice that the tooltip that shows up says struct system.int32. That's another indication to you that it's a 32-bit integer. In fact, even the description says it represents a 32-bit integer. The keyword int actually corresponds to a data type that's defined in the system namespace called int32, and that's the actual type of a number that represents a 32-bit integer. So we have three of those. We have number one, number two, and sum. When you're defining regular local variables inside of a method, the convention is to use lowercase first letters for those variable names. Excuse me. And then in this case, we have number one and number two, where we'll store the first and second number the user inputs, and then sum, where we'll store the sum of the two numbers. Now, we've used, once again, console.write to prompt the user to enter the first integer. Because we chose to use write as opposed to write line, there's no new line character being displayed by default, which is why when I ran the program, the cursor, let me run it one more time, the cursor appeared to the right of the prompt for me to go ahead and enter that first integer. Pressing enter not only submits the 100 to the program, it also forces the cursor to drop to the next line, which is why enter second integer appears there. When I type a value and then press enter, that submits that value to the program and moves the cursor to the next line, which is why sum is appears on the third line. So going back over here, we first prompt the user to enter the first integer. Again, notice the syntax here. The write method is part of the console class, and again, it's a special type of method. It's a static method of the console class. So far, we're only dealing with static methods, but we will get to non-static methods in subsequent examples. So this displays the prompt. Then at line 16, we say that we would like to read from the console a line of text, and we do that by calling the console class's readLine method with no arguments. If I hover over readLine, you can see it reads the next line of characters from the standard input stream. You'll also notice that it's talking about exceptions that might occur. So when I'm reading input, there could be various problems that occur, and those are called exceptions in .NET. And one of the things we'll start doing in a subsequent lesson is talking about the different types of exceptions that can occur, when they might occur, and how you deal with those problems. So just as an example, if I run this program, now remember the program expects me to enter an integer. So if I type hello and press enter, then it says there's an unhandled exception. Let me just cancel this dialog, and it tells me that there was a system format exception. The input string was not in the correct format, and it gives me a bunch of information about that problem that just occurred. When you encounter an error message like this, it's because an exception occurred and we don't have the code in this program that says how to deal with that problem. So for example, one of the things I could do is reprompt the user to enter an integer, not the string hello, and allow the program to continue executing, and we'll show you those exception handling techniques starting in our lesson on arrays. So let me close that. So what we're doing here is we're reading a line of text, which in our case is the first value the user types, and we're passing the result of this highlighted value to the convert.toInt32 method. And if I hover over that, you'll see that there are a whole bunch of overloads of that method. This particular overload receives a string and converts that string to a 32-bit signed integer. Now, if that's successful, it will assign that value to the variable number 1. However, as I hover over the method name again here, you can see that there is the possibility of exceptions occurring, and I just demonstrated the format exception to you when I typed hello where the program was expecting an integer. So assuming the user properly types an integer, that will be stored in number 1. By the way, I could have deleted line 10 and simply declared number 1 right here where I'm reading in the value. That would have been perfectly fine as well. And in fact, we'll start to do that in subsequent examples. I then prompt for the second integer, and I read that value in. First, I read a line of text from the console. I take the string that's returned by readLine. You can see that to the left of the word console in the beginning of the tooltip. It's returning a string, and I pass that into the toInt32 method, which converts that string to a number that's stored in the variable number 2. And as you might expect coming from any programming language, when you add those two variables together, you'll get the result, and I'm then assigning that to the variable sum. And at line 24, we're displaying that result using a formatted string. So here's console.writeLine with a format string that contains some literal characters, sum is, and a space, and then a placeholder for the value of the sum. And what's going to happen is automatically it will take the numeric value of the sum, convert it to a string, and place it at this placeholder position in the output. And that's how we were able to see the sum displayed in the last line of the program. So in this program, we've actually introduced a number of new features. For the first time, we saw how to do some input with the readLine statement, which reads a line of text up until the point at which you press the enter key. We saw the convert.toInt32 method, which converts a string to a 32-bit integer, and number 1 being declared to be of type int is a 32-bit integer, and that's where we store that result. We also saw some operators for the first time. The assignment operator for taking a value and placing it into a variable, and the addition operator for adding two variables together. Now there are, of course, other arithmetic operators that are available to you. So for example, if I take a look at this diagram, you can see that we have not only the addition operator, but the subtraction operator. Multiplication is indicated with an asterisk character, as it is in most programming languages. Division is represented with the / character. And then we also have the remainder operator, which gives you the remainder after a division. So for example, if I have 7%3, that says divide 7 by 3 and tell me the remainder. Of course, 3 goes into 7 twice with a remainder of 1, so the value of that expression in that case would be 1. Now, as you might expect, there are operator precedence rules in C# which are very similar to the precedence rules in other programming languages. The multiplication, division, and remainder operators are all on the same level of precedence. They evaluate from left to right, and they have a higher level of precedence than the addition and subtraction operators do. Addition and subtraction are also on their own same level of precedence. So that completes the addition example. In the next example, we're going to introduce C#'s if statement, talk a little bit about relational and equality operators, and do a simple decision-making program.